Managing operational complexity of high-speed packaging with world-class systems. I hand over the dais to Mr. Sivaram.
Good afternoon, everybody.
Good afternoon.
We had a rather spirited session just now, which dealt with the pack and the packaging. This session will actually look at the process of packaging. Packaging being the ways and means by which we put the stuff into the pack. And now, in doing this, obviously there has been an evolution in the systems and machines. And today's challenges are quite different from what it was, say, 15 years ago. The challenges increase because of changes in fashion, changes in the demand for economy of packaging, and also, of course, the regulatory challenges which many people have spoken about. The regulatory challenges are not only about labeling and the contents, but also the process of packing itself. So before I would like to go a little bit more into this topic, but to introduce it off, possibly we will give you a couple of videos which just show you the process first, so that there can be a connect between what we talk and what you have seen already. So maybe I'll request Samir to first show a video.
Thank you, Sivaram.
Omron is a global automation company with over 200 technical offices and highly skilled application engineers who have years of experience working with our customers. We automate machines. This short video introduces Omron's new SysMac platform, born to automate machines by integrating logic. The new NJ501 is as robust and reliable as you would expect from any Omron PLC. Motion. Unlike any ordinary PLC, the NJ501 is a machine controller, including both PLC and motion control. Vision. With integrated vision, Omron provides an exceptionally capable machine controller. Introducing SysMac Automation Platform, One Machine Control. Created to give you complete control over your automation system. SysMac Studio integrates configuration, monitoring, and programming. With logic and motion in one, the NJ achieves up to 500 microseconds cycle time and 64 axis control. With EtherCAT, the fastest machine network, SysMac includes up to 192 slaves, including servos, inverters, vision, and of course, I/O. Thus, Omron achieves accurate control throughout with one machine network. Also, SysMac supports Ethernet IP for controller-to-controller data exchange and a connection to upper layer. EtherCAT is no ordinary network and achieves incredible performance thanks to its on-the-fly data exchange. Slaves extract and/or insert data on the fly, thus achieving the highest possible throughput. By comparing the timestamp of incoming and returning EtherCAT messages, the propagation delay can be accurately calculated for each slave. This mechanism enables synchronization between slave devices with less than 1 microsecond jitter. Our One software architecture starts with configuration. Simply drag and drop devices and configure the parameters. Programming is fully compliant with IEC 61131, using PLC open function blocks for motion control. A visual CAM editor can be used to create complex motion profiles. And finally, the whole project can be simulated and traced in 3D. Visualize your machine. Sysmac, always in control.
So, ladies and gentlemen, this has given us a brief view of what are the products available which can give us high-speed automation lines. There is another aspect to this of a high-speed automation line. When we talk about managing a complex system, it is not just that you increase the speed, you also have to talk about the uptime, about the operational efficiency and so on. Here, once again, before we actually go into the technicalities of the topic and the question answers, I would like Binu to come and show a little bit of the second aspect of this lines. So there was one more view on the topic, a brief exposure without much text and so on. Now I would like to link the videos with the topic. The topic is about managing complex systems for packaging. Obviously the first question arises, why do you go for complex systems? I mean, stay simple and then life is easier. But as we already indicated, or even the previous session has indicated to us, the demands and pressures on the pack and on packing are increasing, and to cope up with this, the packaging also has to evolve, and in the course of evolution becomes more and more complex. Why does it have to become complex? There are pressures from various directions. One is from the market, that you have to present the product in a good way to the market, and packing is the best way to do it. And if you want to put it in a good packing, then obviously the packaging has to be nearly perfect. Second, there is a pressure, as already somebody said, the per piece cost has to come down. If the per piece has to cost to come down, the lines have to become more efficient. And for lines to become more efficient, you have to think of energy, you have to think of maintenance, and you have to think of various factors. And this obviously adds complexity. And thirdly, the thing comes from also the regulatory bodies which impose certain restrictions, not just on the packing, not just on labels, but also on the process by which the material is being packed. That you need inline inspection, you need tracking, you need tracing, etc., etc., etc. And finally, I would say, by the very nature of the consumer market, that there is a need for change for the sake of change. Okay? So because of all these pressures, definitely marketing has to become more and more flexible, has to do more things for more people in shorter time, and which needs definitely a complex system. Fine. Then how does automation come into this? Automation is the tool, here I will say more than everything else, is a tool by which complex systems can be handled in a simple way. This is ultimately the bottom line of automation, that an operator who is not a rocket scientist can still handle a complex system. A maintenance engineer who is not some postgraduate from Harvard or something can still maintain a complex system. And automation has to work towards this direction. But can automation do this by itself? Yes and no. There are two ways in which automation actually acts with the packaging lines. If you look at the packaging line, there are three stages through which it goes through. One is at the time when you select the machine, select the line, design the line, and get it installed. The second stage is the actual operational phase. The operational phase, of course, is the longest period in the life, and there obviously the questions of energy efficiency and maintainability and uptime and OEE and these things do come up. But also there is a third phase where we typically at the beginning do not think so much, is of upgradability and renovation and expansion and extension, which inevitably every manufacturing line, including packaging, has to go through, given that the technology evolves, the user requirement evolves, the regulatory system environment evolves, everything evolves, and you have to think about this. And in all these three aspects, automation has certain solutions already, but they can be used only if the users will choose it intelligently. Now, is it a matter of there being a buffet and being chosen? No, it's not always like that. Many a time also the pressure comes from the market onto the automation and say, this is what we want. And can you give it to us? And this guy will say, okay, after 1 year I will be able to give you a product like this. Or sometimes it also so happens that the automation comes up with a brilliant product and presents it to the market and says, look, this is there. Now you think what you can do with this. So it is not only one which is pulling this, but it's a mutual pull, and they have to march kind of step in step. Sometimes one goes a little ahead of the other one, but on the whole there is a harmonious progression. So now the rest of the discussion, I would like to take it through the three parts. That is, the first part being the initial design and selection and installation and so on. The second part is the production life of the plant as it goes through. And third is about the other topics of how do you expand and how do you also perhaps look at some of the human angles, because ultimately even if it's automated, you do need people to run it. So we will go through these three different stages one after another. At each stage I would say that we will have a kind of a introductory PowerPoint, and then we will have a question answer session, and during the questions we will welcome also the audience to participate and ask more questions or give more answers. Either way, yes? So we could have interactive. So first PPT, I think Binu will show, and then we can throw up the questions.
So good evening. First of all, very thanks to the organizers of the conclave to give us automation suppliers and also the OEMs a forum to speak about the new technologies available. So what would I like to present to you is a dream of the packaging industry. What you can read on the screen is optimized packaging line. And to the real sense of the world, it's a dream that the packaging line is fulfilling on all the demands that the challenges that are there in the for the packaging industry to take over. Through my presentation, I would first of all bring in front of you what are the challenges that the packaging industry in the whole world and especially in India is facing, starting from the design phase and then the operation and then the upgradation. Secondly, and what answers Siemens has in terms of starting from design phase, plan, operation and also for the upgradation. So we will move ahead. As being a football season and the soccer cup starts in next 2 days, I would like to give a football kind or soccer twist to the presentation. So even the champions face challenges, even Ronaldo has challenges. So that's okay, and so our packaging industry also has challenges. What are those? First of all, the primary objective, we want to build a world-class plant, a high-speed plant which can give me high productivity. What does high productivity mean? Minimum cost of production per case. This was what the gentleman also told us earlier. Reduce efficiency drop after startup. That's a phenomenon that occurs in packaging lines. I'll also brief you in detail what this efficiency drop phenomena is. Create transparency and reduce OEM dependence. What does transparency mean? There are multiple machines working on in a packaging line, but we need data, production data, the uptime data, the downtime data, the production rates, the rejection rates. Until and unless this data is not available, no corrective actions can be taken. So there is a transparency required, and the end user wants to take over the machines as fast as possible from the OEMs. And that's what OEM also wants, move over to the next plant. Last and the most important, reduce total cost of ownership. But when all of these topics come together, which I showed here, all of them take a back seat when the most important guy comes on the table, which is called capex. And like it happens in majority of the decisions, and especially in packaging line is also not a difference. The capex takes a front line, and the decision makers look at how much investment they are making to set up this packaging line. But especially in packaging, because we were talking about that how complex packaging lines are. Being so complex, they have a lot of challenges, which is so peculiar to this industry. And the cost that is involved with spares, maintenance, service is huge. And that aspect is always on the back seat. So that's where the challenges lie and how we can take over or approach these challenges. If you look at any plant, for example, in the country or also globally, we'll see, because this trend is still in a nascent stage, how the packaging lines can be fully optimized. We will see it's a total diversity inside the plants, and that's because the packaging industry is such that it is an amalgamation of different OEMs coming together. Because these OEMs are technology experts, they are domain experts. For example, an OEM will be an expert for capping, or for example labeling, or for example he will be the expert in the world for filler, but he might not do the palletizing. So it's an amalgamation, all these 3, 4, sometimes 10 OEMs come together and set up this packaging line. But what happens is, because of less deliberation in the design stage, there is a very big diversity inside coming to the end user's plant. What it is, I will just like to share with you here. For example, this is one machine from OEM 1, OEM 2 giving a second machine, OEM 3 delivering a third machine. If you look at the controls, a PLC controller from X make, an HMI from Y, similarly a drives, Similarly, the second machine is totally different, varied, because this automation is selected by the OEM, and the OEM selects this automation based on the best fit controller, the best fit network, the best fit HMI for his machine and his process. But and also the OEM does not make the machine specifically for a specific end user. But unfortunately, when all these machines come together inside the plant of the end user, it's like a museum. And the biggest challenges start moving on from there. First of all, the diversity. What does it affect? Because of so many different items, they are all high technology products and not very freely available in the market. They have to have a very big backup of spares, and immediately the cost starts building up. Similarly, complexity. Now they are human beings who are running these plants. They are the guys who are running, they are the process experts, but they are not the experts for controlling or programming a PLC, a drive or a servo. So imagine the poor guy who's the operator or the maintenance guy learning first this PLC, then this one, and da-da-da. Similarly, the network diagnostics, he has to learn everything, and it's not possible to learn. So that's where the second problem comes, which is downtimes. Then the third one. Now if we want to build high-speed lines, it is not possible if these machines don't talk to each other. It's only possible when the downstream machine is talking to the upstream machine. That whether I'm producing, I'm down, I'm out of material, I'm out of labels, or XYZ reasons. But how do they talk to each other if there is a difficult system integration? For example, a machine Y is having a data interface. What is a data interface? Data interface is, in very simple language, the status of a machine. For example, I'm producing, or I'm in fault mode, or I'm out of raw material. There are a basic state mode of the machine. And if I'm in fault mode, what are the reasons for that? So that's a basic state of the machine. So if this data interface is the structure that takes this state of this machine to the higher level for some decision making to happen. But if this data interface is in some English, or for in easy language, I'll say this machine is talking English and this machine is talking French. How do they interact? That's the problem number one. And thirdly, we have also some machines that have no data interface. They have a PLC but no standard data interface which can be linked together to control these machines in tandem. So that's a big problem for the end user. Similarly, diagnostics. Again, if the end user operator is not able to work on different softwares, he's not an expert, he cannot also diagnose what are the faults, what are codes mean, and what action he has to take. It's impossible. And then comes the asset costs like the spares, and then the maintenance that comes to it. I was talking to you about a phenomena called the startup efficiency drop. This is the phenomena that is the end user's misery. The OEM starts the commissioning, the production starts in a good ramp up, and they achieve the 100% promised production rates, and then they start leaving because they have to move to another plant, and the plant gets handed over to the maintenance engineers and the operators, and then comes the issue. They are not aware of the automation, they are not aware of the softwares, they are not aware of the diagnostics, there are different reasons, and then the efficiency drops because machines are not performing, they are on fault mode, or they are not giving the production that they are made for. And there comes the drop in productivity, and there comes the losses for the end user. So, how all these challenges can be taken care of or can be addressed to in a very cost-effective manner. That's what my next segment of the presentation will be. We at Siemens call this approach as optimized packaging line approach, and it's a highly modular approach because as complex lines these are, it's also not easy to implement it's not easy to change the scenario complete 100% in one day or in one project. So it's also modular, and an end user can select that I want to go ahead with one approach. For example, what are those approaches? I'll brief you. First of all is line integration, because the basic reason we need to integrate these machines is we want to achieve higher speeds. So there are standards available, global standards, globally acceptable standards like OMAC and Weinstefan, especially for the beverage industry, which is called the Weinstefan, on which we can integrate these machines and get the data interfaces. And they are easily programmable, no additional cost is required. From any PLC, this data interface can be made, and which can be passed on to the second machine, which is on the downstream, and so that the downstream machine can take an action based on the production or the non-production activity of the upstream machine. Similarly, line visualization, how do I, now when the data interfaces are there, I need to see how my machine is performing, which machines are producing, which are the problem creators. I will see always, okay, my capper is always creating a problem, so that means that's the problem. And because of that, the downstream machines are stopping. So once I start measuring or seeing the results, then only I can control. Similarly, network diagnostics, documentation, technical guidelines for selection of hardware. That's another module where Siemens adds value. Technical consultancy, this is very important, especially for the end users. Everyone in the project team of the end user is not an expert who writes specifications, detailed specifications that the OEMs can follow. That's where Siemens can consult and help them with specifications, with standards, not only Siemens hardware, but standards which can be followed by the OEMs very easily, and so that the end result at the end user's place is in order. Similarly, training, ready to run standard applications to develop these data interfaces are also available. So what would be an ideal plant look like if all these modules are implemented? Standardization on the hardware, the end user selects based on his confidence which hardware he wants to use, which hardware he wants to standardize. If he standardizes on one PLC, and I'll say not one PLC, if he standardizes on one model of a PLC, then he asks the OEM, the second OEM, that I want this model of the PLC itself, so that he can reduce the variety in the plant. Okay, here comes the second point, that OEM might say that it might not fulfill my performance that I require from the PLC. That's where we have a lot of options where we can have a scalable automation solutions or automation options for the end user. Similarly, on the data interfaces, there is one standard data interface either on OMAC or on Weinstefan, which can be generated easily with the same PLCs and the motion controllers. On line integration, the OEM selects which network he wants. Is it Profinet? Is it Ethernet? Whichever is the best one available for him. Then comes the big picture, how his plant looks. When he wants to monitor it, what are different machines, starting from a blow molder. For example, this is a line integration view of a beverage line, from the blow molder to the palletizer, which all machines are there, and at these LEDs will show him the actual status of the machine, whether it's producing. If the green is steady, it means producing. If it's flashing, it means it's okay, but it's waiting for some machine to deliver, the predecessor of the machine. An additional approach is a line controller. What I showed you here is only visualization. But if you want to also optimize on the conveyor speeds, how I increase the line speeds, you want to maintain the buffers in between the machines, then the line controller can add additional value and control the buffers, control the speeds of the conveyors. If a downstream machine is stopped, it will not stop the upstream. It will still keep on delivering until the buffer is maintained, so that there are no frequent startup and stop of these machines, which is a problem. So this is the optimization which the line controller can give. Then comes reporting. When the data is there, I can take all key data like OE, TCO, whatever specific KPIs are required for the end user. Then comes most important, energy. When these machines are integrated on a network and a standard network, it's very easy to tap up the energy consumption data and show which are the machines which are consuming more energy, and then corrective actions can be taken. So overall, it reduced the total life cycle cost of the machine and the plant. So at a glance, this concept helps the end users in saving the life cycle costs, creating transparency from the field level to the, for example, if he wants to install an MES, it can give them production data right from the field to the MES, and also increase productivity. So that's our goal for all of us, the end users to have higher productivity, for the industry to have a standardization, and for all of us good results, right? Thank you.
Very good. Excellent. How does this go? Okay. Now there is a nice, very elucidative presentation, possibly packed with a lot of information, but I think the highlights were there. Essentially, one thing stands out, that whereas packs are sold in a local market, customized for the local audience, local populace, packing machines or lines are actually sold worldwide. Everyone would like to export and send it across and so on, and that itself is a challenge. Now, one of the first questions that arises out of this is, somewhere he has kind of indicated, and in the last presentation also I am always carrying on from there, we feel that the packaging lines are particularly, let us concentrate about the speed of the lines. The speed of the packaging lines in India is not at the global standard. It's a kind of a presumption, I would say, but possibly may not be much contradiction with that. Now, question is more important, how important is it in India to increase the line speed? What is your experience?
Can I?
Yeah, please.
Yeah, here I'm representing the OEMs here in this forum. And from my experience, I've been in this field for more than 25 years now. I've seen how this whole process of, I can at least talk about the vertical form fill seal and horizontal form fill seal, where as Bosch is more involved, and my experience also relates there. I've seen how once we started with the individual equipments. In vertical form fill seal machines, we said that there were days, okay, when we said 50 bags per minute, then we achieved it was a good speed. Then the challenge came was how to integrate with the filling systems, like dosers or scales or something like that. That's where the automation came in. And the next step was we moved into next level of speed at about 80 packs per minute speed. And now we are talking about 140, 150 packs per minute on a vertical form fill seal machine. On a horizontal form fill seal machines, we are talking about 300, 400 packs per minute. When we scale up these machines, the challenges also comes in. Yes, as manufacturers, you have a lot of challenges, like the product has to be perfect, a lot of issues and the raw material, on packaging material, operator skill levels, that's a lot of things. So we will not go into those details today in this session. Because here, from my experience, what I've seen is how automation has helped to scale up the machine speed. It was very critical. If you go into like what Binu has highlighted here, there are a lot of the selection of correct equipment plays a role in improving the efficiency of the machine. Like the response time is so critical. The diagnostics are so critical. You see, this makes a lot of influence on the machine performance. So there are, if you like, and also we now, if you see in our Indian market, not only the best technology, we have to also be cost efficient and give the right solution. It's a big challenge for the OEMs. And when we do that, we have, if we choose the right selection, like for example, I'll tell you, like earlier, we had servos separate, the drive separately, motor separately, PLC separately. Now, if you really integrate the whole solution, one is as a whole package, you make a lot of advantages like modularity, commonality, there are a lot of other advantages. In addition, as a manufacturer, we also save a lot of things like we save a lot of time in wiring, for example, the assembly of the equipment. We save a lot of time which can be passed on to the market. So there are a lot of hidden costs which we are able to really optimize by choosing the right set. So this topic I feel is quite relevant today. Okay, and the next step today, after the individual equipment, today we are moving to lines. And when we talk about lines, and when we are talking
Sir, you
about...
are already jumping a couple of my questions before I ask you answering it.
Yeah.
But I think we would ask the questions one at a time so that everybody gets a chance to
Sure. I just want to give this my experience here. And
no, it's very valuable. But what I'm thinking is there are also people out there who have also spent years and years in this field, and we should
sure.
make a nice this thing out of it. So, in a follow-up to this question, I would say that when people ask for high line speeds, what are the challenges? That's where I wanted to come to Binu.
Yeah.
What are the challenges that a vendor faces? Automation vendor. I mean, okay, he asks for more, and we say, okay, this is what it is, and then immediately some other counter question comes and says, no, I can't pay you 1 million.
From my experience, I'll tell you, the basic issue that an automation vendor faces is that these machines are not able to talk. I'll say to talk means they are not able to talk in the language that we want to understand. So for example, if I want some data from this machine, to bring it and integrate in these different machines that are in downstream, I don't have a standard data interface. I don't have a PLC which is able to give this data to me. So for a person who is integrating a machine, for example, a system integrator comes into a plant and there are 10 different machines. For him, finding the right bits, right status of the machines from the logic of the PLC is a nightmare. And that's where the costs for the end user builds up, because he has to spend so much time into each and every PLC. For example, there are 7 different PLCs. He has to look at different seven logics and bring out those bits. For example, the production rates, all those counters from those logics, and then bring them to the common database. So that's the biggest challenge. And that's where a deliberation is required, that any end user puts a machine, he always thinks about that I want a standardization on the data interface, because that will help him to move over, to upgrade in an easy manner.
Here, of course, 2 views are possible. That a choice leads to competition, and a competition leads to benefits to the user, and that's what you would always normally look at. And yes, there is an advantage of standardization in terms of whatever you have just now told, and these two have to be weighed from time to time. And I think we will deliberate on that in the next, during the operation cycle, how these things matter, actually speaking. One other question which I have here is, like for an OEM, a machinery manufacturer now, when he wants to choose a particular automation, not just a brand of automation, but even a level of automation, like how sophisticated do I want to make this machine, then what are his criteria, and how much is he influenced by the end user? Because when you are designing the machine, possibly you may not know which end user is going to buy next year or 6 months down the line. So you have to make certain designs. So what are your challenges? Leading up from your earlier question.
The challenges is really, when we design a machine, we design for a cost performance ratio, and it's also designed for a particular purpose. The idea, the many times which we face is we don't come across a supplier who can provide the entire platform to us in a cost-effective way. This is the big challenge we face.
Is it that you are sometimes forced to dumb down the machine before you give it to a particular user? Does it happen?
Sorry?
I mean, you have a very nice sophisticated big machine, and then if a particular application or a user you feel he is not either ready to accept it or will have challenges in running it, would you take out the more complex parts of it and make it more simple? Is it a doable thing? Is it a good thing?
It's finally any commodity what we make, it should be saleable in the market. This is what. So particularly when we design a machine, what we do is some of the features which finally for the Indian scenarios, which is not more relevant. So what is important is what we do is the modularity is very important. What we take is like or any controls what we do, the add-ons at a later stage, the options to upgrade this in a course of time. This is a critical factor because we need to have we have to satisfy different cost spectrums, cost level. So your machine should be upgradable, adaptable. Like today a customer is buying a machine. He may use it as a single machine. Tomorrow his business increases. He want to add 3 machines and he want to integrate it. He want to make it automated. So the machines, whatever we do, what we keep in mind is should be upgradable, can be adapted to the requirements. This is a challenge we always keep in mind.
Then we talk to another point that maybe Samir can answer this. Since you made the presentation, the same question I want to put to him also, that if there is not the machine being handed over to the user, but when the automation is being passed on to the machine manufacturer, what challenges does the automation vendor face? Because this is again a complex topic.
Let me put it like this: it's not about challenges that the automation supplier or the end user faces. I think there are some protocols that need to be followed, some things that need to be taken care of while doing the handover process. Because it's very easy to put a high world-class automation on a machine, but at the end of the day, it must run at the end user. It must give all the benefits that we talked about when we actually sold that application to the user. And from that point of view, the onus rests on us as the automation suppliers and the automation industry in general to actually ensure that the OEM as well as the end user are first of all trained in the usage, are trained on the equipment. So training needs to be very strong. The second point that we need to take care of is the after sales support in terms of availability of engineers, because these machines are meant to be used 24/7. They don't you can't use them for once a week or something. So if there is a breakdown, if there is a challenge, if there is an unforeseen problem, then how quickly can you get it up and running? There are tools available, Sivaram, about remote diagnostics. I think everybody is aware. Tools are available for online support, but I think in many cases you need to have physical feet on the ground. So it's important to have a widespread network of service engineers who are stationed all across the country. And as somebody mentioned before, a lot of machines are actually not used in the country that they are manufactured in. So we are now talking about a global support. So you must have, so what it calls for is a standardization of solution across different countries, across the globe, and so that you buy, for example, an equipment from Omron, and if you send it along with the machine to maybe somewhere in Italy, then it should be possible to get it serviced in Italy by an Italian Omron engineer. You don't have to fly a guy down from India. So I think these are some of the things that the automation industry must take care of to ensure that the automation that we are providing does its intended purpose and does it better than expected. Otherwise, we will never have the OEM coming back to us. Forget about the end customer.
Yes, any feedback from the audience?
Yeah, I have.
Yes. They are searching for the mic. Wait. Yeah, we found one.
You want to go first? First of all, I've not come across such lucid presentations, and they have been integrated in this way and through these questions. So I think this panel has been pre-planned and it's been done the automated way. I think this is excellent because one thought was flowing into another.
Sir, just to break, actually we planned a lot of previous interaction, but ultimately we had 2 minutes over the tea to interact. So it's more a meeting of minds and of a external force driving us all into the same direction than something coordinated here. But anyway, please.
2, 3 observations come questions. One is that to the Bosch gentleman that you are, I think, still selling a whole lot of standalone machines.
Yeah.
When do we get to the stage of integrated lines? Because if we have to compete with China, and we are talking of scale and speed, then we need integrated lines. The chalega nahi, the standalone business, number one. Number two is what happens with all the fluctuations in voltage and frequency. What happens to automation in Delhi, for example, at the current point of time? That is my second question. And the third question is that when you standardize so much, aren't you worried about your competitiveness? Because if Siemens can be integrated with everybody else, do you fear, or does your company fear that your competitor will become equal to you, and therefore, while you may promote this at a seminar, on the ground you may be actually selling specialized systems? And I'll tell you why. I'll give you 2 examples. One is in the edible oil industry, and this is something which you guys can work upon. When the pack comes out of an edible oil machine, the seal is still hot. So the edges of the pouch are very sharp. So if it goes and hits the pouch in front, it causes a micro puncture, and then there is a leak in the marketplace. Now the easiest solution is to link it with the cartoning machine. And if it's cartoned immediately and it goes through, then this will stop, but none of the edible oil companies will do it. But the first company which is now doing it in a big way is Bunge. But they are going for a specialized system because their OEM said only I can give you the solution. So the standardization goes out of the window. And secondly, Bosch will know this. They supply to Tata Salt these salt packing machines.
Yeah.
And you see these huge 50 kg bags lying all over the place. You see these workers carrying these bags on their back, salt coming, and each machine standalone, utter confusion. Why those salt lines can't be integrated?
It's a very relevant question. Actually, for Bosch, worldwide, we are known for supplying line solutions. In India, when we started the operations, we realized we faced a lot of challenges. Of course, there were a lot at the back end and in the front end, and as I said, the utilities. There are a lot of things that has to be improved. But over the years, I think now it's the right time. Many of the customers are now thinking in this line, and it is now easier for us to convince a customer. If a few years ago, if you talk about OEE or TCO, nobody would listen to us. They said we really don't want to talk. If you see a biscuit factory, if you go into a biscuit factory, you can only see people there. Nobody, you hardly you can find any machines or anything. So the trends. This is now there are trend centers in the market. Some of the customers are taking this lead because they are finding the benefit of automation. They're finding the per pouch cost. Now running cost is now the capital cost is capital cost is important, but the running cost has become very important talking point now for our sales point now, and we are already in this now. So this is something definitely it will come, and we are geared up, and we have already tied up with our automation solutions, and now this is what's going to come definitely. And you said about salt. Yes, even in salt conditions, we have big challenges there. In salt, secondary packaging of salt. Yes, we can put a baler and automate it, but it doesn't work because Indian logistics still today need a HDPE and SAC.
You got to take some standard precautions, of course. You don't.
But that's still a big challenge because one of our biggest warranty cost is replacing the failure of this electronic components. There are some of the parts of the country still there are extreme spikes, which is a big challenge. Only is from the government infrastructure side, these things have to improve, and from the equipment manufacturer side, yes, over the years it has improved. Our protections have
Maybe if that's
But
the case, they
still
need
big
to put
challenge.
standard into
I-
UPS or
I
something.
think the
Specifically.
standardization dialogue has to be slightly shifted in focus. Standardization on a given brand has certain benefits. We cannot deny it has been a traditional approach. But today we are moving to a stage where possibly standardization on the technical features, on the protocols, on the common user interface like a PackML, on a common open protocol platform for intercommunication and so on, will then give both the benefits, one of the standardization for the use, and second, as I said, more choice and therefore more competitiveness in the market, which will drive also the vendors to continuously improve and compete. So I think standardization has to be looked up today at a different perspective. Now, he has put his finger on a pain point of all vendors about the failures in the various parts of the country. Certain things are acts of God. Certain things, as he said, are act of the government or whatever it is. Okay, but also there is a large extent which are acts of man. By which I mean not sufficient care or attention being followed to the standard procedures which are provided by the vendor and say you must hold on to this, but which on day one when the OEM supplies it everything is good, but from day two onwards it slowly goes on decaying, and then suddenly there is a failure. So some aspects, let us say as automation supplier or as a machine manufacturer, are out of our control, but some things are in our control.
Certainly. It helps, like for example, when there is places where there is extreme spikes, when the power goes and comes, immediately if the machine automatically switches on, then there is a chance that, so instead you use a push button and start, when in extreme situations where there is too much spike.
Or a delay relay,
or some
delay.
Solutions available.
There are solutions. That's why this. Yes,
There are workarounds.
There
I
are.
will call them solutions.
Yeah, there are. We need to. Yes.
Yeah.
Protection mechanism.
Protection mechanisms.
Yes.
So anyhow, I think we also have a limit on the time because there is one more.
I think
this is a seminar
question.
afterwards, and he is getting restless. So now let's move to the second part. That is, we are talking now about the operation stage. The line is set up, it is running, and everything is supposed to be smooth, and so on. And now, how to keep it running, and how to keep it running at the speed where it was designed in the day one. This is once again, I would say, a contrast between India and the more advanced or more industrialized countries. And here I think Samir could share a PPT first, and then we can once again go through the same. Search for this.
Okay, this is the topic that I had. Sivaram wanted me to address is about, yes, you have, we are talking about, really world-class automation solutions, advanced automation solutions, highly complex machines, high-speed machines. And then when it goes to the field, how do you ensure a very high uptime for these machines? Because the people who bought these machines bought them to produce all the time. So the way we see it is, and I'm going to address it in these presentations, what is the expectation? This is the agenda that I have, and the first thing that we're going to look at is what can, as a user, you expect out of an investment in a world-class automation system, because it's an investment. Key features that help you improve the uptime in any such system, and of course the conclusion. Of course, I am referring to Omron here. That's where I get my salary from at the end of the month. But of course, but a lot of things that we talk about here are generic and can be at least in different parts, being done by most suppliers, if not all. So, a very simple slide on what is it that a user should expect out of an investment in a world-class automation system or a complex automation system. The first thing is, of course, is a higher reliability and uptime. It doesn't make sense to invest in something complex and probably also more expensive, but if it doesn't give you a better reliability and uptime. The next aspect is safety and productivity. That means safety without compromising on productivity. Our environments are demanding more and more safe operations, and this is really a must. But should safety be a hindrance to productivity? No. Actually, a good automation system can help you get there. A higher throughput and reduced wastage. Again, a no-brainer. Producing a more consistent product quality. Yes, of course, you want to produce the same quality throughout the batch. A reduced spares inventory, and in case of a problem, fast diagnostics and a support in case of any failures. And how does a good integrated automation system help you achieve this? This presentation, I would like you to see it as a next level of what Binu presented. In terms of, he talked about line automation, and I'm actually talking about a little more detail about machine automation. So that's the background behind it. Now, I think the first and foremost requirement for having a really good automation system with a guaranteed or a very high uptime is to have an integrated solution. Because an integrated solution means that you actually end up using lesser components. And when you use lesser components, there are less chances of a failure. And of course, when you use less components, you also have to have a lesser spares inventory. And again, I mean, it's very intuitive, but I think we need to dwell upon it a little more. It's very easy to get carried away by buying the cheapest component for everything. The cheapest PLC, the cheapest sensor, and the cheapest drive, and the cheapest motor, and then try and put it all together. It would work, but it would be a nightmare from an operation point of view, from a maintenance point of view. And that is where an integrated solution helps. It reduces wiring. It reduces, because you can have everything on a bus. It gives you better diagnostics. I'm going to talk about that a little later. But a higher reliability is a matter of design. It starts by choosing an integrated system as a first step. And what do you mean by an integrated system? Something which includes the inputs, sensors, vision, of course the PLC, and also output devices like robotics and other expellers and other things. Okay, what should this integration include? Should it be flexible? Yes, of course, because one of the demands that we face from our OEMs is, and they face in turn from their customers, is about flexible manufacturing. How quickly can you reconfigure the machine when the product sizes change, or when your product capacities change, or something like that. And this is where these come in. And robots, for example, are something that are coming into the picture now as the machine speeds increase. Some applications are simply not possible at a higher speed by using manual intervention. I mean, how easy, how difficult, or how strenuous it can be if you imagine somebody palletizing a 1 kg juice pack, which is coming out at like about 40 packs a minute. There is a person sitting, physically lifting a 1 kg pack, palletizing it. 40 packs a minute. Really strong biceps. And that is where, as machine speeds in India increase, we will find more and more implementation of robotics. Of course, that's adding a complexity to the machine operation, to the automation, for sure. But if you choose the right system with the right integration, it can really help reduce the complexity while improving the flexibility and performance. And that, of course, helps in reducing the wastage. The other thing that is really in today's quality inspection, inline inspection, vision cameras, I think just about, and this is not a new technology, this has been there for about 30 years now, more than 30 years, but it has evolved over a period of time, it has evolved quite a lot. We had today, and we had this interesting discussion in the previous session about 2D barcode reading, 3D barcode reading and all that. This, for example, I can relate an example of pharma industry, where the track and trace applications are now a mandatory for anybody who's trying to export to US, where not only as the pack is being produced, the barcode that is printed on it has to be unique, has to be read, has to be recorded and stored, so that the person who buys the medicine 6 months down the line, somewhere in the other part of the world, can scan it using a mobile phone and actually verify whether the medicine is authentic or not. Or if it's counterfeit, then you can smell it out. And what does it call for? And all this when the machine speeds are increasing. So what does it call for? It calls for a very reliable inspection technology. And it's something that is really integrated into the entire automation system. It is not an add-on piece. It's got to be a part of the package. Thus, this is something that can also help meet regulatory requirements as well as improving the uptime. Safety. No compromises here. Of course, the Indian work environment has changed dramatically over the past few years. Safety is now no longer a fancy practice which is being followed by just a few MNCs or by some other a few customers. This is now becoming almost like a mandatory requirement on every shop floor. But there are various aspects to safety. There are of course standard safety things, light curtains. You cross the light, the machine stops. But is that what you want? When you are producing something at like 100 packs a minute and the machine stops, it takes a lot of time to just clean the machine. Forget about restarting it afterwards. Is that what you want? Just because somebody by mistake crossed the line and or opened something and the machine stopped? Perhaps no. This is where addressable safety devices can help. These devices help you set limits and warning zones. Help you configure them based on the machine state. For example, when you're starting up the machine, perhaps you want a lesser range for the safety device because a lot of people are around the machine. But once the machine is up and running, you want an extended range because you don't expect anybody to be around it. But when you're doing maintenance, then what do you expect? You are very, very close to the machine. Then the range has to be really small. So there are scanners available in the market, and these scanners are on a network. So it's very easy to reconfigure them, to configure zones in these scanners, so which can be defined as warning zones and or safety zones. So there are zones. For example, you can define a warning zone 2, where the machine speed actually slows down but doesn't stop unless the person or whoever the intruder is comes into the safety zone. All of this is possible today with the automation systems that the industry can provide for the OEMs and for the users. And of course, all these devices now come on a network. So, which is again very easy. You don't have to go around changing each and every device. This is something that can be done online. Integration with MES. Again, my colleague Binu spoke about this in terms of when you want to do, a line integration or even a machine integration. How do you want today all the information, and in some industries like pharma, it is a regulatory requirement to have that information on an MES. It could be an SAP, it could be a BAN, just an RDBMS, just a relational database. How easy it is for you to do that. Today, options are available to directly connect from the PLC to an RDBMS. So you don't need a lot of hardware. You cut down on a lot of hardware and software, and thus reducing the failure points in the entire chain and the entire system. This is something that again we feel that could be of immense advantage to the industry in terms of improving not just the uptime but also meeting the regulatory requirements. We had some discussion about sealing earlier as well. Heat sealing is perhaps the most used and the important aspect in packaging, especially in F&B industry, where not only is it a good thing to have, it's good, it's a mandatory thing because you want to have a high shelf life of the product. And no customer is going to buy it if there is a problem with the heat sealing itself. But it is also one of the most complex applications, for example, because every time the jaws close, the temperature drops. The next time the jaw closes, it has to be the right temperature. You have it too hot or you have it too cold, the sealing is not going to be perfect. I think many people sitting here know about it much better than I do, because you experience this pain perhaps more often than several times a week perhaps. This is where new function blocks, new PID control loops like DPC, DPC is of course something patented from Omron, or something special from Omron, but this is something, optimal temperature controls, that help not only make sure that the jaws are at an optimum temperature at every seal, but also at the time of startup. How do you make sure that every time you start up the machine, the first pack is a saleable pack, the first output is a saleable output, and this is where at least the heat sealing part of it is taken care of by these controls and these algorithms. Again, something that comes today with the automation that you buy. Okay, if there is a problem, what do? We have sold this nice beautiful piece of automation, and now let's say there is a challenge, or forget, even before there is a challenge, even if an OEM, if you want to study the machine dynamics, take care of some of the other items in the machine, maybe some gearbox or something else that needs to be looked at or retuned or something like that, there are remote diagnostics available today. So an OEM or the automation equipment supplier can log on to these devices, to this automation, and actually take a download or even change, update the firmware or the software, and take a machine diagnostics without having to physically put people on the ground. It's not just about people, it's also about the time that it takes to put a person on the ground. Usually it could be a few hours at least before the guy can reach there. So again, a technology which I think we would like the packaging industry to make use of more and more. They're yet to catch on, quite frankly, in India, but still something that has an immense potential for the packaging industry. So in conclusion, selecting an integrated system by design when you build the machine is perhaps the best thing that you can do to ensure a high productivity and quality while maintaining a very safe environment during the operations. That was really my presentation. Sorry if I overstepped the time. Thank you.
Anyway, I would like to ask you the first question as a follow-up for this. Now you have shown us a lot of complex modules, technologies, etc. One of the main purposes of installing a production line, is to have a high degree of uptime. And there is a huge perception that the more complicated automation systems actually reduce the uptime. What is your take on that?
If you see, my entire presentation was on the fact that if you have a more automated system or more advanced system, the uptime actually goes up. And this is really true because for the very simple reason that these systems have been built with a lot of experience that has come from the field. And the customers, our customers, are demanding a higher reliability, a higher uptime. So the systems are designed to perform like that. Some of the features that I talked about, so I'm not going to repeat, things like integration, things like remote diagnostics, and the fact that within the system you can have good diagnostic tools and all that. But some of the things, for example, consider in case there is a failure, or can you hot swap the equipment? Yes, you can. Doesn't mean you have to power off everything. Just replace the faulty part and you're back online, which was not really possible with perhaps some of the other automation systems, which is possible today. If you look at connectivity, today we talk about EtherCAT. Okay, we talked about EtherCAT. Maybe there are other networking solutions as well. Earlier, all of this used to be hardwired. So today you can simply change a drive or a servo and the system takes care of setting it up and reconfiguring it, and your machine is up and running. Earlier, people had to struggle, and you know it. You had to really tune it and make sure it worked right, and of course, wiring it itself was a challenge in the first place. So I think as the systems have advanced more, they have built-in functionality which is helping improve uptime, which is helping reduce the maintenance costs, which is helping reduce the requirement of people to maintain these systems. So you have things like remote diagnostics, we spoke about it, you have lesser amount of hardware that is there. And all these systems, most of them at least, come with built-in diagnostics. So it's no longer. I remember the earlier system when I started to work. If there was a problem somewhere, all you would get is an alphanumeric error code, and then you had to look through a manual to check what does it mean, and then you tried something and hopefully the code changed. But now it's much more intuitive. Now you don't even need perhaps an engineer to handle some of these systems. They are that easy to use,
There is, perhaps I could just add to this, that there are typically the downtime occurs out of two different reasons from the control system, from the machine itself, not from the product or not from some incorrect feeding or something, not manual errors. One is a failure which arises out of a regular wear and tear or an aging of a particular component, and the second is a kind of a random error which happens because of maybe an external influence, over voltage or whatever it is. It is in fact endeavor from the industry as a whole, I would not say any particular vendor, whether it's B&R or whether it's Siemens, whatever, that the machines now will tell you that there is something going wrong with me. Not that something has failed, but that they will tell you a little in advance that something is going wrong. Why don't you come and check it? This is broadly covered under the bigger umbrella called Industry 4.0, where the industry has become more and more this thing. There are, of course, still it's a long way to go, but on labs these things are already there. Takes some time. I think wanted to.
In addition to, I second this. Like we always have a concern when we go for complete automation, put all the machines together in a line. If something fails, the whole line stops. But actually, that's where the reliability comes from, the system design comes. And I will give you one example, when you have, let's say 5 wrappers connected to a process line, but if sometimes machine failures you can avoid. There will be some printer which may fail or something may fail. But in that case, when you have an automation, you can have already provision to take the product to a refeed or a buffer storage, and when the machine is back, you can automatically feed back this. So you don't need to again pack this in a manually or get into bins and all those headache. You don't need to do that. And there is also, like Samir said, the sealing technology. This is an important step which is taking place with all the machinery manufacturers. Now what this technology is coming up such that if you have 5 machines, if one machine is down, then the 4 machines can ramp up to take that speed also. You don't need to have a refeed or a buffer. That's very critical. That means the sensors, the reaction time, the quality of components, everything is so critical, so that when one machine is down, immediately that the heaters, they solve, because the packaging material has lesser time to seal when you are running at high speed. So all this automation flexibility can come with the technology.
Just to add to the point that Samir was showing in his presentation about different zones the sensor can, and similarly what action the drive system or the motors behaves. For example, an intruder is approaching the machine quite close to it, but we don't need to stop the machine full. There itself, the drives have integrated safety options available these days, and the automation industry itself is developing there and giving some standard basic safety options like a safe limit speed. That's the feature where if the intruder has approached to a danger zone but he is not very close to it, the automation system delivers the command to the drive and it goes to a safe limit speed, and it does not go to the peak speed. So the productivity is also not stopped, but the safety concept is also kept intact.
So you wanted to ask?
I'll take you back to what you mentioned.
Yeah.
You said that it's a very common occurrence that after an OEM supplier delivers a line, at the time of delivery, the output levels are delivered, but then there is always a sharp drop, and there is a learning time and a learning curve. As an industry, have you tried to find out why this happens? That is my first question. My second question is, why can't you design training programs to see that does not happen? Because if I'm an end user and I have a new automated line, the last thing I would like is for the line to fail because of the lack of quality of the operator.
Absolutely.
I think this has to be handled in 2 different ways. One is training on the automation per se is about the automation products and not about the process or not about the machine. The machine vendor has to train about the machine. Okay, so these 2 things are slightly different, and yes, I agree with you. To keep the line going up and running, we do need a pool of people who are well trained in automation, how to install, how to commission, how to maintain, how to diagnose, how to repair. And this is a big challenge in terms of skill development as a whole, because this is a high end and it presumes a certain amount of basic information also. But the AIA, the Automation Industry Association, is doing a lot of efforts on this. Somewhere down the line we will come to that point also and we will address that. The third point, I don't know, maybe he will say it. I have experienced many a time that we get 14 maintenance engineers or 20 operators to come and attend a training, but on day 2, half of them disappear because there is an emergency on the shop floor, and the owners of the equipment do not pay so much attention to the training as to the purchase of the equipment.
Yes.
What is your experience, sir?
That's where in my presentation I have stressed on the topic of the module called information and knowledge sharing. That's one of the basic building block to a high-speed packaging line. And that has to happen not once the machines have been installed. It has to begin when the discussions with the OEMs are on. At that time, we finalize and decide what automation will go into these machines. And from that moment, there is a time of around 5-6 months based on the different kind of a packaging line that they are putting to train your engineers on these technologies, especially the motion, the automation, safety, diagnostics, everything. So that's where the industry itself or the packaging end users have to keep this as a specific reminder that their people have to start trained from the orders being placed rather than when the machine is getting set up. Because then once the machine is getting set up, it's all about production and the quantities that come out of the machine.
I just want to add one thing which we learned from other industries and maybe packaging should also adopt. Supplementing to what Binu says, if you have already identified that you're going for automation and identified the people who will ultimately maintain it or operate it, it's a good thing to have a review with the supplier before you do the acceptance testing. You know, maybe about 80% when the project is complete at the vendor's end, send your trained people and ask them to look at what is being done. In all fairness, you will want changes to be done. Because when you ordered the equipment, your people at the ground level were not consulted. They were not even aware. It was some top management thing. But these are the guys who are going to be your new owners. So it's good to send them, let them brainstorm, let them force any changes to be done, because changes done prior to supply are always going to be well engineered, well documented and well rounded. So there's a lot of new ways we need to think about how are we going to get into this world of automation. It is very exciting, but at the same time it requires a lot to be done on the competency building.
So then would the industry like to accept as extended supplier responsibility that they will deliver the kind of training which can avoid this kind of a problem?
Absolutely, and to make it easier for you, we are also in the process of setting competency development centers around the country, which are going to be housed, in college facilities, where it's very easy for you to walk in, learn theory, which again makes a lot for long time, capability building, and also most of our members would be there in the labs with their equipment. So training, theory and exercise and experimentation are all necessary components for you to absorb the competencies which are in these companies and take it into your own organization.
Sir, you have to, I think this. Sir, one other point which you have to hold is that when you supply a machine or you buy an automation and you train the people who are there at that time, that does not solve your problem because people change. After 6 months, after 1 year, so you need a college kind of thing or a continuous training establishment where you can train and retrain the people all across. Sorry, you want to-
Yeah, no, just to add on to what you just said, this is really the fact of life. I mean, the people will leave, new people will come. And I think many times the customers forget, I would say, under work pressure to actually get these new guys trained. So that reminder comes only when there is a problem. And then, you find out that, these guys they cannot handle because they were not trained. So what we request is for the industry is to keep sending people for training. Let it be refresher courses. These are not big ticket items. These are not big expense items. And every automation supplier, at least has these kind of courses running. And I can say on behalf of Omron, Binu, Siemens, everybody. And I'm saying most people have their own training centers where you can send people. We can train them in a classroom environment with actual practical hands-on kind of training. But the industry or our customers must take the initiative to keep people getting retrained all the time. So, sorry.
Yeah, Samir, we are badly running out of time, and I think we have time for one more question because that is, I think, is very important. After the machine is set up and it's running for some time, the demands on it change, increase, or some products become obsolete. It always needs some kind of upgradation, renovation, and modernization. Now, for example, some of these new things which come in are even belonging to a technology which is not already there on the shop floor. Like, for example, an RFID or a machine vision or something comes in, and now there is a challenge for everybody, for the machine builder who has built the original machine, the end user. The vendor can bring in a new product and say, okay, this is something which you have developed 6 months ago, but to integrate it is not with the automation vendor. You need an ecosystem which will do this. Now, for example, how does Samir or Omron deal with such a situation? Because you have shown a lot of innovative products. And how do you find the guys who will actually do it?
Yes, it's a continuous challenge, and as you rightly said, it needs the involvement of the OEM because it may require a change in the mechanical setup. But some things we don't have to go back to the person who actually, or the OEM who actually made the machine. There are system integrators available, or other companies available, domain experts available, who can actually modify or add on to these machines. Let me not say modify, at least add on to these machines. For example, I can relate practical examples without giving names. There's a user who would like to now integrate a vision system for inspection and then use some kind of an eject mechanism for rejecting the faulty packs where the printing is not perfect. Now this is a requirement that has come up now because the market is demanding a better quality. The market is demanding that every time you print the company's logo, it really must be the perfect logo that is printed. No compromises. Or every time you print the MRP or the date, there has to be no compromise on it. But it's possible. There are suppliers available who can do it, and we are working with some of these suppliers. So yes, you're right. It's an ecosystem. It's a challenge, but it is doable, and there are specific people available, system integrators, domain experts available to handle these kind of things.
Good, I think we have so much more to share, but time is always a constraint. At the conclusion, I could say that yes, we started out with the premise and said we are somewhere below the global benchmark. If I would look at it in three different ways, one of the automation availability, automation what is available in India is the same as what is available elsewhere. And I think the machines to a large extent, as at least the technologies that are being used and implemented are same as elsewhere in the world. The end users produce the same products but for a different market requirement or for a different consumer expectation, and therefore maybe there is a bigger difference. The 2 points which have come out really as differentiators and where we need to still work is one is a little bit out of our hands, that is the external power system and voltage and heat and dust and whatnot. And the second thing is, which we need to work all of us together, that is the end user, OEM, the integrator and the associations, is on building the human culture which accepts and adapts this automation and becomes as friendly to it as to the earlier box screws and mechanical cams and so on. I think do you have time? One time for the one question if something comes up from the audience. Anybody? Last chance.
I think you had a question, right?
My question has actually been answered to a large extent, which was that because Binu Thomas said earlier that the problem is that these machines don't really talk to each other. How to make them talk to each other. Now, within the discussion, you people have answered that to a large extent by saying that there's an Ethernet protocol, there's plug and play, there's hot swap, and there's also PackML. So my question earlier was that, similar to Mr. Chidambar's question, that is this, or to Dave's question, which is that, is this something that companies are just paying lip service to and still running their proprietary systems? Or are machines really able to recognize and talk to each other? Is the communication in both directions? And is PackML really going to work in that sense? I mean, how popular is it? How quickly is it going to catch on? How easy is it to build machines to the standard without worrying about integrating them quickly and easily and economically in what I would say, not a line. I think what you now have no longer have packaging lines, but you have packaging systems or packaging rooms with several machines and lines.
It's a very nuanced question. Who would like to challenge? Take a challenge first.
Okay. Let me give it a try.
This is the last one.
Okay. First of all, no, it's not lip service. Let me put that up because it's business case for us, for the automation suppliers. for a very simple reason that plants keep adding machines. And just because they are using one particular supplier does not mean that every time they add a new machine, they must always go to the same supplier. Because that would actually tie them down to one vendor, which probably nobody wants. So there are enough practical examples of different PLCs or different automation systems, so when I say different, from different makes or even different generations talking to each other over these languages. I think there are enough examples across the world and in the country as well. The second answer, yes, there can be challenges sometimes. There is still some engineering work that needs to be done, and this is where some of the vendors have set up some facilities for this kind of thing. At least if I can give example of Omron here, we have dedicated labs where, and across the world and even in India, where we can actually check out these communications, test them out before doing it on the field. So we can actually test them in a laboratory setting, make sure it is all working fine, develop the software, the application for it, and then just go and simply port it on the customer's premises and give that extra bit of confidence to the customer that it works, and of course saves on the commissioning time and the uptime there. I hope I was able to answer your question, sir.
Yeah. Just to add to what Samir said, like you asked that is it actually possible? I can cite you examples of beverage lines which have now standardized on Weinstefan. They want only Weinstefan because on that they can also integrate the barcode reader or the spray paint, the labelers. So it's happening, and if you want, we can take you to some places where this actually OMAC or Weinstefan is working, and that's the trend which is catching up, and that's why we are discussing all this. I feel that's the thing that we took up from last year's conclave, and now it's developing.
So I think really speaking, it is actually still a WIP.
Yes.
In the sense that the technology is available, it is ready, people know what is the use of it, but everybody is looking at who are the big players who are actually going and implementing it. So it will go step by step. But the benefits are realized, benefits are accepted, and the vendors are ready. So now the buyers have to now gear up. I think